So this is Unit 6, Lesson 1, Angle Measure in Degrees. Okay. So in this unit, we'll consider angles, standard position expressed in degrees and radians. So we hit radians tomorrow. We develop and apply equations of the unit circle. You guys, I don't think any of you guys had me for 20, but I define the unit circle in 20 when I teach it. There's a project we do on it so that you don't memorize it. I was telling Cash, memorizing is kind of a hard thing to understand the concept. So I remember when I was your age, I was told to memorize it. That kind of helps, that makes you kind of miss the patterns, okay, which kind of is not the point. But we will go over it again, unit circle, so they do have it as a lesson. So you'll see it. Okay, so rotation angles in standard position. So angles can be measured in degrees where 360 is one complete rotation. So 360 is a circle, we know that. Okay, all the way around. A rotation angle is formed by an initial arm. So initial arm is like where you're starting. The terminal arm is where you're going to. Okay, so that's what this is, the terminal arm, the initial arm. Okay, the angle formed between them is the rotation angle. The angle shown in the diagram is said to be in standard position. Standard position, we start at 0. But technically, we can move our position and still have different angles, different places. But most of the time, we're going to be going from 0. So from, they call this line right here standard position. So like if I'm looking over here, the unit circle on the right, that's your standard position. But you could look here, and what's the angle from here to here? You can just still do that. Okay. All right. So on a coordinate grid, standard position becomes the initial arm is along the positive x-axis and the rotation about the origin. So a positive angle is going no, that's clockwise, right? That's counterclockwise, yeah, thank you. So positive is counterclockwise, and then negative is clockwise. So if from the same spot here, if you see an angle of 235, you're going to go, so this is 90, 180, 235, right? So you're going to 235 degrees. Counter, negative 90, negative 180, negative 247. Okay, so you're going the opposite direction. So yeah, like I said, a lot of numbers you're going to want to kind of know, be able to count 90s, because you're going to like 90s are the kind of key locations, stuff like that. Okay, so it says sketch the rotation angle in standard position and state the quadrant in which the angle terminates. So review of quadrants, we talked about this. Remember, it's 1, 2, 3, 4. That's your quadrant numbering. That is not something you're given on the diploma exam, so you do need to know that. Remember, start with the positive section. So 290. 290 would be right there. Okay, so that's 290 degrees there. It ends in quadrant 4. It ends in quadrant 4. Okay. So yeah, negative 135. So here's negative 90. So negative 135 is going to be right around here. Quadrant 3. Yeah, and 750 is just kind of tedious because all you got to do is just take out the 360s. Okay, so we know 360 times 2 is 720. So it's really only 30. It's going to come right there. Okay, yeah, if you want to draw the circles, that's fine. If you want to go 360, 720, and come around, sure, you can do that too. Okay, everybody okay so far? Okay, so this one's quadrant 1. All right. All right, so the point A lies on the terminal arm of the rotation angle theta. In each case, draw the angle theta in standard position. So what they're saying is we are going to go and plot this point on our grid. Okay, so negative 3, 4 is over here. And then essentially, so let me do a different color here. So this is your angle theta that's formed from that original position. That's why they say standard position. So like, for example, if we guesstimated, this angle is probably 100-ish, 110, right? Here's 90. It's a little bit bigger than 90. Okay, so if you're guesstimating what it was, you don't know what it is, but you could figure it out, but we'll talk about that later. Okay. So -7, -2. So that means we're in quadrant 3, negative, negative. So 1, 2, 3, 4, 5, 6, 7. 1, 2. So right there. So then let's go back here. So it's going to be there to there. So your angle theta is right here. And so that angle is bigger than 180, right? It's going to be, maybe 200. Okay. All right. So it's coterminal angles. So draw the rotation angle in standard position. So we're going to draw these in standard position. So 150. So we're going to be right about here. 150. Okay, -210. So we're going to be right about here. Okay, and then 510. So 510 is, let's see here. If I subtract 360 from that, it's going to be 150. So you can go all the way around if you want. You're going to go, again, 360 plus 150. So I'm going to be in that same spot we're at. The point is, these are called coterminal because all of the arms land in the same place. All three of these angles are called coterminal because they have the same arm. Now, look at it. Watch. 150 this way, right? What's 360 minus 150? 210. And so 210 the other way. So they land on each other. Okay? So these are coterminal. They're the same spot. And then 510 is 360 subtract from that. So if you go 510 minus 360, you get the 150 again, so you land that 150 spot again. So all three of these are essentially the same location. So coterminal means they share the same position. Okay, any questions with that? Exactly, good point. There's infinite amount of coterminal. I'd keep adding 360 forever if I want, right? Get as many as I want. Okay, or subtract 360. Okay, so the three rotation angles above are called the same terminal arm, called coterminal. The principal angle of set of them is the original. So for example, the principal is the positive between 0 and 360. So the principal is 150. So all of these line up with 150, but they come from the principal of 150 is what they're talking about. So principal is kind of the positive normal angle. Okay? All right, so yeah, diagram is 150. Okay, and then to what Aiden just said, the set of angles coterminal to 150 can be written as a pattern of 150 plus 360n. So it just means add 360 as many times or subtract 360 as many times. So it's good because we have to write it n equals integers. So positive, negative whole numbers to answer your question there. So you know how we always put NER? So it's not NER, it's NEI. NEI means n has to be an integer. Okay? All right. So it says determine angles theta in the domain of between -360 and 360. Which coterminal would be given? Write an expression involving the principal angle that represents all angles in that domain. Okay? So what we're doing is, so 285 is the positive 360. What's the negative to land on that spot? Right, so you go 285 minus 360, and so the negative piece is -75. So these two pieces both land at the same arm. Okay? And so then write which number, 285 or -75? Which one's the principal? 285 is. So we're going to go so this is part A. Part B is we're going to go 285 then plus 360n. Again, n has to be an integer. Okay. Yep. N is a number. So what this means is, so you know how Aiden said there's infinite amount of coterminal? Yeah. Every time I add a 360, it's a coterminal angle. So n can be any positive, negative whole number, and those will represent coterminal angles. So if I said your n was -6, I would times this by -6, add this to 285. I have this really big negative degree, but it would be coterminal because I multiplied 360. So n is number of times, yeah, n is number of times you multiply 360, which is, we don't know. Like, you can do as many as you want. It's infinite. So you're confused is correct, because you're like, well, what's it stop at? It doesn't really stop. It could be anything. Okay? All right, so -13 is the negative. So what's the positive piece? How do we get that? Add 360. So we go -13 plus 360. So it's going to be what? 347? So 347, which one's the principal? 347 is, right? Principal has to be the positive. Okay, principal we want the positive piece. So then we go 347 plus the 360n again, NEI. All right, so for C, they give us one bigger than 360. So we want to figure out the principal then. So what is it? Right, 395 minus 360. So the positive guy is 35 degrees. So that's the positive. It does want us to get the -1 too. So what's the negative? What's the negative? Right, 35 minus 360. And so you're going to get the -1 is -325. So there's your positive and negative coterminal arms. And the principal is 35, so then we write 35 plus 360 N NEI. One more time. Okay, just got a couple. We'll just go to reference angles, and then we'll be done here. A couple examples.
Are we only doing one lesson?
Yep. All right. So reference angle. So a reference angle, I always just let me say this before I read this. The reference angle is simply the degree back to the x-axis. So no matter where you are, it's the degree back to the x-axis. So if I'm here, it's this piece. If I'm here, it's this piece. If I'm here, it's that piece. Okay, always going back to the x-axis. So probably pretty hard for the video to see that. So let's go here. That's a reference angle. That's a reference angle. That's a reference angle. That's a reference angle. Back to the x-axis every time. Okay, so a reference angle is the acute angle formed between the terminal arm and the rotation of the x-axis. The diagram shown at the terminal arm of 120. The reference angle is 60. So they're saying is this right here, this angle, the rotation is 120. So if we want this angle, we know these two have to add up to what? 180. So this is the 60. That's where they got 60 from. Okay, so that's again knowing that mental math there. Okay, so 120 is the given value. To get all the way to the x-axis, it's going to be 60. Okay, so we're going to do a couple of these here. You might see the pattern, but please ask questions if you need to. Okay, so let's look at these three. So where is 243? So 243 is going to be right about here. So I want this angle. So how do I get it? 243 minus 180. That gets you that chunk there. So 63. So 63 is that reference angle. All right, so 337. So that means we're going to be all the way over here. 337. So how do I figure out this piece? Right, 360 minus 337. Okay, so you're going to get 23. And the last one is 70. So what's that one? 70. Okay. And so they're just going to kind of give you the proof here of how to find it in each spot. I think you guys kind of get it, but we'll go ahead and just go over it real quick. So how you find in each spot is in quadrant 1, it's just equal. Your rotation equals your reference. The 70 equals 70. In quadrant 2, you have to go 180 minus that angle. Okay, so you'd go 180 minus the rotation. Okay, down here, it's going to be 180, sorry, it's going to be the angle minus 180 to get it. But they're giving you how to get the rotation angle. So we're talking about reference angle now. We'll go back to talk about rotation. Let's keep the same with reference. For the bottom 4, to get the reference angle, it's 360 minus the angle. Now to find the rotation, you do 180 minus the reference. So if you have the reference angle, you would 180 minus. Same for quadrant 1, still equal to. The rotation on this one's 180 plus the reference. So you have your 180 plus the reference will get you the rotation. And the last one is going to be the 360 minus the reference will get you that one. So that just shows you how to go back and forth if you're trying to find rotation versus trying to find reference. Okay. Let's just do these 2 examples and call it a day. Okay. So for these 2, we got state the reference angle for each of the following rotation angles in standard position. Okay, so we're stating the reference angle. So 195, 15. Right? It's 15 degrees past 180. Okay. So you can draw these though. That one's kind of quick, right? 195 is right here. I go 195 minus 180. 15. Okay. So negative 258 is a position. The reference angle will still be positive. Reference angles are always between 0 and 90. Can't be 90. So we need to figure out where is negative 258. Well, negative 258 means I'm going clockwise. Okay, so it's going to be here's 180. So that's 270, so it's going to be right about here. So I'm getting it from there. Okay, so negative 258. So that, to me, when I think about it, is how much bigger is 258 than 180? Or you can write, what is this for the positive? I mean,
78.
This is 78? Oh, you mean the answer 78? Yeah, the answer 78. Okay, good. The answer is 78. That's correct. 258 minus 180, yeah. Yeah, it is negative 258, but we know it's 258 degrees, and we're just going to subtract the 180 of it to see what's left. That's fine. You also could do, you also can figure out what is this in the positive piece. So the positive piece of this is going to be 102. I think it's 102. Yeah. So that's 102. So then 180 minus 102 is also 78. So you can kind of go either way. Again, if you get a reference angle that's bigger than 90 or negative, you did something wrong. Okay, so try to figure that out in terms of where should you be. Okay, so negative 810. All right, so that's going to be twice around for 720, and it's going negative, so 1, sure 2. Okay, and then we have 90 more. No, 90 more, right? It's going to be right there. Okay, so what does that mean? So that is the max it can be. So if you're ever at these 2 spots, it's 90 back, either way. So it doesn't matter which way you go back, so it's 90. Right, so just simply 90. Okay, so for reference angle, the biggest one you can have is 90, and that's when you're on the y-axis. So if you're on the y-axis, you're going to be 90. And if you're saying, well, which way do you go? It doesn't matter, right? 90, 90. Okay, so it doesn't matter. Okay. Questions?
And then if it's on the x-axis, 0?
Right, if it's on the x-axis, it's 0. Yep. Good. Okay. All right, so determine the 4 angles between 0 and 360, which have the same reference angle as the rotation angle of negative 128. It's a great understanding question. It's making you figure out what are the 4 spots that give you an equal reference angle. And this is important because when it comes to all this stuff, guys, it's symmetric in a way. Okay, so first off, let's do negative 128. So negative 128 is going to be right about here. Okay, so before we do that, let's figure out what that is positive. So this is negative 128, or what is it? 232. Okay, so what is that reference angle? 52. So this is all you have to do. 52 here, 52 here, and then 52 here. And then go find what those three are. Okay? So the reason we got the positive first is because it says we want 0 and 360. So I got the positive first because of that. So we know that the quadrant 3 is 232. Quadrant 1 is the easy one, right? 52. We usually have to find quadrant 2 and quadrant 4. Okay, quadrant 2 is going to be 180 minus 52. 128. Put these degrees on here. And quadrant 4 is 360 minus 52, so 308. And so there is your 4 angles which have the same reference angle of 52. Okay, any questions?